Hello everyone, welcome back to my YouTube channel. In this video, let us solve numericals on efficiency of single phase transformer for different loads. You can see the numerical. A transformer is rated at 200 kVA. kVA rating they are given at full load. Full load means the value of load is 100%. In absolute, you can write that as 1. Here I'm considering the load as X. The value of X is 1 for full load and its copper loss is 1000 watt and its iron loss is 920 watts. Calculate the efficiency at full load unity power factor. Means when X equals 1 and the power factor is 1, we need to find the efficiency. And efficiency at 3 by 4th full load, that is when X equals 3 by 4 and power factor is 0.9, we need to find the efficiency. So now can see the given values. Before that, I'm defining formula now only. Percentage of efficiency is given by X is a load into VA rating. They are given in terms of kVA. You have to convert that into VA. That is why I'm multiplying by 10 to the power 3 into power factor. That is cos phi divided by, that is nothing but output power divided by output power plus total losses along with the load. That is XVA rating into cos phi plus PI means iron loss, PCU means copper loss. You need to write the efficiency in terms of percentage. That is why you are multiplying by 100. So you can see the VA rating they are given 200 kVA and iron loss they are given 920, copper loss they are given 1000 watt. So you need to find the efficiency at full load unity power factor. That is when X equals 1, cos phi equals 1, VA rating you know, PI you know, PC you know. So just substitute the values, you'll get the efficiency at full load. That is when X equals 1, power factor is 1. So that you can see efficiency is 1 into VA rating is 200 into 10 to the power 3 into power factor is 1 divided by 1 into 200 into 10 to the power 3 into 1 plus iron loss is 920 plus X square, that is 1 square into 1000 into 100. Substitute these values, you'll get the efficiency for full load as 99.05%. So be careful while substituting the values and do it around say substitute around say you just have to get the exact answer 99.049. So I'm writing that as a 99.05. Similarly, efficiency at 3 by 4th full load, that is nothing but when X equals 3 by 4, that is 0.75 and power factor is 0.9. We need to substitute the values to this efficiency formula so that 0.75 is X into 200 into 10 to the power 3 is a VA rating into power factor is 0.9 divided by 0.75 into 200 into 10 to the power 3 into 0.9 plus 920 plus X square, that is 0.75 square into 1000. So substitute the values in your calculator neatly. So you'll get the efficiency, but for 3 by 4th full load is 98.91%. Okay. Similarly, the next problem. Here a 600 kVA single phase transformer, that is kVA rating they given, has an efficiency of 92%, both at full load and half full load, that is nothing but half load. They given efficiency for full load and half load, that is 92%, and power factor for full load and half load is unity power factor. Calculate the iron loss and full load copper loss. Once after finding this PI and PCU, determine efficiency at 75% full load, that is nothing but when X equals 0.75 and power factor is 0.9. So first I'm defining the formula, that is percentage of efficiency is XVA rating into 10 to the power 3 power factor divided by output power plus total losses, that is PI plus X square into PCU. Then see the given data, VA rating they are given 600 and efficiency for full load and half load they are given 92% and power factor for full load and half load they are given 1. So now iron loss and full load copper loss, to find that first you need to consider for full load X is 1, power factor is 1. You know the efficiency, that is 92%. So either you can directly write the absolute value or else you substitute it as 92 and multiply on the RHS. And X is 1, VA rating is 600 into 10 to the power 3 into power factor 1. And the only unknown values are PI and PCU. So after substituting this, next we'll get 0.92 equals 6 lakhs divided by 6 lakhs plus PI plus PCU. So you just interchange these two, 0.92 and in denominator, we'll get 6 lakh plus PI plus PCU equals 6 lakhs divided by 0.92. So once after doing the simplification, send the 6 lakhs to right side. Then you do the simplification, you can get PI plus PCU equals 52,173.9 watt. If you want, you can write as it is, or else you can convert that into kilowatt and write that is PI plus PCU equals 52.17 kilowatt. Similarly, from half load also we'll get one more equation of PI and PCU. So for half load, X is 0.5, power factor is 1, they are only given. The same simplification you are doing. Here 92% is equals 0.5 is for half load, 600 into 10 to the power 3 into 1 divided by output power plus, we don't know iron loss as it is, plus X square, that is 0.5 square into PCU. So again you are doing the simplification and interchanging this denominator and LHS side, we'll get one more equation, that is PI plus 0.25 PC equals 26,087 watt, or else you can write in terms of kilowatt, that is PI plus 0.25 PCU equals 26.09 kilowatt. So you're getting two equations, two unknown equations. You can use a calculator and solve equation 1 and 2. You'll get the value of PI as 17.4 kilowatt and PCU as a 34.77 kilowatt. You can use calculator in the EQN mode, that is equation mode. So once after knowing this value of PI and PCU, then they are asking you to find the efficiency at 75% full load, 0.9 power factor. Therefore, efficiency for 75% full load, which means that X is 0.5, 0.75 and power factor cos phi is 0.9. Therefore, use the formula percentage of efficiency, substitute the values. Now we know the value of PI and PCU, that is 0.75 into VA rating is 600 into 10 to the power 3, power factor 0.9 divided by output power plus, the iron loss is 17.4 kilowatt plus X square, that is 0.75 square into PCU, that is full load copper loss is 34.77 kilowatt. After substituting these all, you'll get the efficiency for 75% load, 0.9 power factor as 91.64 percentage. So first you need to calculate PCU and PI with the help of full load and half load. You'll get two equations. Solve these two equations with the help of calculator. Then you substitute these values in this efficiency formula. You'll get the answer as 91.64 percentage. And the next problem is similarly a 250 kilovolt ampere single phase transformer has 98.135 percentage efficiency at full load, 0.8 power factor lagging. So now KVA rating is 250, 98.135 percentage of efficiency for full load, 0.8 power factor, and for half load 0.8 power factor, the efficiency is 97.751 percentage. They're asking you to calculate iron loss and full load copper loss. Again, the same thing. From full load, you'll get one equation. From half load, you'll get another equation. Solve that with the help of calculator, you'll get the PI and PCU. So that you are using the formula of efficiency, I'm defining now only. Now you write the given rating, they are given 250 kilovolt amperes, power factor 0.8 for both half load and full load. Full load efficiency, half load efficiency, they are given. So from full load, X equals 1. You know the efficiency, that is 98.135 percentage. Either you write multiply on RHS, you multiply 100, or else you can directly write the absolute values as 0.98135. And you know the X value is 1, 250 into 10 to the power 3 power factor they are given. Only the unknown parameters are PI and PCU. Substitute these values and you interchange LHS and the denominator term of RHS. Then you simplify this equation. You will get one equation, that is PI plus PC equals 3800 watt. Similarly, for half load, when X equals 0.5, we know efficiency, we know the X value, we know the kVA rating. Only the thing is that PCU, we don't know. You substitute these values, you'll get one more equation, that is Pi plus 0.25 PCU equals 2300 watts. So by solving these equation 1 and 2, you'll get the value of iron loss and copper loss. PCU is 2000 watt and Pi is 1.8 kilowatt. So take care while substituting the values of Pi and PCU in a calculator. Do the simplification properly. Then you'll get the answers 2000 and 1800 watt. Okay. Similarly, the next problem is in a 25 kVA transformer, iron loss they are given 350 watt, copper loss they are given 400 watts. Calculate the efficiency of transformer for half load UPF and 3 by 4th full load 0.8 power factor. A simple, a straightforward problem. They are given, you are defining the formula, and they are given VA rating, that is 25 into 10 to the power 3. Iron loss they are given, copper loss they are given. You need to find efficiency for half load unity power factor and 3 by 4th full load 0.8 power factor. So that efficiency for half load unity power factor, for half load X is 0.5 and cos phi is 1. You are just substituting the value. You know X is 0.5 and VA rating is 25 into 10 to the power 3 and power factor is 1 divided by output power plus iron loss we know, that is 350 plus X square, that is 0.5 square into copper loss we know, that is 400. Substitute these values in your calculator properly, then you'll get the efficiency for half load as 96.52%. Similarly, for 3 by 4th full load, that is X is 3 by 4, that is 0.75, power factor is 0.8. Substitute the value of X 0.75 into VA rating is 25 into 10 to the power 3 and power factor is 0.8 divided by output power plus Pi we know 350 plus X square, that is 0.75 square into 400. After simplifying this, we'll get efficiency for 3 by 4th full load as 96.31%. The next and last numerical, a 100 kVA single phase transformer has an efficiency of 96% at full load 0.9 power factor. Means kVA rating they are given. Efficiency for full load 96% with respect to the power factor of 0.9 and 92% at half full load, that is for half load efficiency is 92%, 0.8 power factor. They are asking you to calculate the iron loss and full load copper loss and also determine the efficiency at 75% full load, 0.8 power factor. So first you are defining the formula, then you write the given VA rating, they are given 100 into 10 to the power 3. Efficiency for full load 0.9 power factor, they are given 96. Efficiency at half load 0.8 power factor, they are given 92%. So now with the help of that, from full load efficiency we'll get one equation, from half load efficiency we'll get another equation of Pi and PCU. Then you solve with the help of calculator, we'll get the value of Pi and PCU. So that for full load X is 1 and power factor is 0.9 and you're substituting here 96% is equals 1 into 100 into 10 to the power 3 into 0.9 divided by the same thing output plus Pi we don't know, X square is nothing but 1 square into PCU into 100. We're getting 0.96 equals 90,000 divided by 90,000 plus Pi plus PCU. Interchange this 0.96 and denominator. We'll get 90,000 plus Pi plus PCU equals RHS. We just simplify this and send this 90,000 to the right side. We'll get Pi plus PCU equals 3750 watt or else 3.75 kilowatt. Similarly, from half load, when X equals 0.5 and power factor is 0.8, you will get one more equation of Pi and PCU. And efficiency we know 92% and power factor we know 0.8 and the value of X is 0.5. Only the unknown parameters are Pi and PCU. So that 0.92 equals 40,000 divided by 40,000 plus Pi plus 0.5 square, that is 0.25 PCU. Interchange this denominator and LHS side. You will get 40,000 plus Pi plus 0.25 PCU equals 40,000 divided by 0.92. And we just keep this as it is, send 40,000 to the right side and simplify. We'll get Pi plus 0.25 PC equals 3478.3 watts, or else you can write that as 3.48 kilowatt. So now we are getting two equations, and you solve this with the help of calculator. We'll get the value of Pi as 3.39 kilowatt and PCU as 0.36 kilowatt. Once after knowing these two values, find the efficiency at 75% full load and point it power factor. Use the formula of efficiency. X into VA rating, that is 0.75 into 100 into 10 to the power 3.8 divided by output power plus, and this iron loss and copper loss were calculated. Substitute that value and simplify this equation. We'll get 94.35% as the efficiency for 75% full load, 0.8 power factor. So these all are about numericals on efficiency of transformer. If you are having any doubts regarding this, feel free to write in the comment box. Thank you. Have a nice day.